Welcome to the session on parametric equations using trigonometric identities. The objectives for this session are to convert parametric equations into Cartesian form using trigonometric identities. We can use trig identities to convert trig parametric equations into Cartesian form. In this session, we will always consider angles measured in radians. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. A curve has the following parametric equations: x equals sine t minus 2 and y equals cos t plus 1 for t in the real numbers. We are required to show that a Cartesian equation of the curve is x plus 2 all squared plus y minus 1 all squared is equal to 1. So let's solve this. Now x equals sine t minus 2 implies that sine t equals x plus 2. We also have that y equals cos t plus 1 implies cos t equals y minus 1. We know that sine squared plus cos squared is identical to 1. And so we can now plug in the values of sine and cos in our example into this identity, as shown. To give x plus 2 all squared, here of course sine t has been replaced by x plus 2, plus y minus 1 all squared, and here of course cos t has been replaced by y minus 1. And so we have that x plus 2 all squared plus y minus 1 all squared is equal to 1. And therefore we've solved part A. Now let's take a look at part B. Using the same parametric equations as in part A, we are required to use the equation x plus 2 all squared plus y minus 1 all squared equals 1 to sketch the curve. So let's solve this. Now clearly, this equation is the equation for circle, so we're required to find the centre of the circle first. Here are our x and y axes. Since we have x plus 2 all squared, we know that the centre of the circle, or the x-coordinate of the centre of the circle, is x equals minus 2. Since we're adding to that y minus 1 all squared, we know that the y-coordinate of the centre of the circle is y equals 1. Therefore, the centre of the circle is at minus 2, 1, as shown. Now let's find the radius of our circle. Since x plus 2 all squared plus y minus 1 all squared equals 1, the radius of our circle is equal to root 1, which is of course equal to 1. So we can draw a circle around the centre of the circle as shown, with radius 1. And this is the curve that we're required to sketch. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. A curve C has the following parametric equations: x equals 9 cos t and y equals 1/3 sec squared t for t between minus pi by 2 and pi by 2. We are required to find a Cartesian equation of C. So let's solve this. Now since cos t does not equal 0, we can divide our equation by cos t. So x equals 9 cos t implies 1 over cos t equals 9 over x, as shown. We also know that 1 over cos squared t equals sec squared t, which is equal to 9 over x all squared, as shown. If we substitute this in y equals 1/3 sec squared t, we obtain y equals 1/3 9 over x squared. And tidying this up gives us y equals 27 over x squared. Now let's take a look at part B. Using the same parametric equations as in part A, we are required to write down the range and domain of C. So let's solve this. Now from part A we have that y equals 27 over x squared. And given the range of values of t, we have that cos t is between 0 and 1. So since x equals 9 cos t, we have that x is between 0 and 9. And therefore, 1 is less than 9 over x. And so we have 1 is less than 81 over x squared. And rearranging this gives us 1/3 is less than 27 over x squared. And this is of course equal to y, which is what we were leading towards. And so we have that the domain is 0 less than x less than 9, and the range is y greater than 1/3. And finally, let's have a go at part C. Using the same parametric equations as in part A and B, sketch the curve C. So let's solve this. Now from parts A and B, we have that y is equal to 27 over x squared, and we also have that the range is x greater than 0 and less than 9, and the domain is y greater than 1/3. So here's a sketch of our curve. Here's the range, and here's the domain. This brings us to the end of this session. If you have understood its contents, you should be able to convert parametric equations into Cartesian form using trigonometric identities. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.